Hello everyone, here's your experiment 5, not 9, which is determination of the solubility product KSP of calcium hydroxide. We're not going to be using the experiment 5 that is in your textbook if you already purchased it, but instead you can use this handout which I posted on Blackboard. Okay, so in this experiment we try to find out the solubility product of calcium hydroxide in two different ways. Just like the pre-lab experiment questions that we did, pre-lab exercises, it's going to be the same procedure. You're going to be using 10 milliliters of 0.3 molar sodium hydroxide in a 10 milliliter graduated cylinder. You're going to pour it into a small beaker, and then you're going to add 0.5 grams of calcium chloride, and then you stir it, let it be there for 5 minutes, and then you vacuum filter it, and you try to find out the pH of the solution, and from that we can find out the KSP. And then after we vacuum filter it, you're going to isolate the solid. You pour that solid into another beaker, add 50 milliliters of water and make a saturated solution, and then you calculate the pH again and then calculate the KSP from the saturated solution. Okay, so those are the two methods we're going to be doing. So basically in your first method, just like your pre-lab assignment, you will take 10 milliliters of 0.3 molar sodium hydroxide solution. To that you're going to be adding calcium chloride 0.5 grams or 5 grams. 0.5 gram calcium chloride. Okay, 0.5 grams calcium chloride. I already wrote calcium chloride together. Okay, and then what's going to happen when you have sodium hydroxide and calcium chloride? It's going to form a white solid. So sodium hydroxide plus calcium chloride gives you calcium hydroxide, which is the white solid plus the sodium chloride. Okay, and then once this solid is formed, you're going to take the pH of the solution, and then you vacuum filter it, and then make a saturated solution again by adding 50 milliliters of water, and then get the pH. So those are the two methods we're going to calculate the pH. And then the data sheet is posted for you with the mass of the calcium chloride used. I will go ahead and write it down over here again. 0.5 gram is the mass of the calcium chloride used. Volume of the sodium hydroxide 10 milliliters. Molarity 0.3 molar. And then the filtrate, meaning once you initially made the solution, the filtrate pH 11.5. And then the saturated solution pH 12. Okay, with this data we can do our calculations. Using the original mass of calcium chloride and the volume of the solution, it was dissolved into calculate the initial calcium concentration, which is easy. So you take 0.5 gram calcium chloride, convert it to moles. 110.98 is the molar mass of calcium chloride. And then this volume, this mass is in 10 milliliters. So when you divide the number of moles by the volume, converting it to liters, this will give you the molarity. So grams to grams cancel, moles over volume, that's going to be the concentration of the molarity, which is going to be, you can do the calculations for yourself, and you might get a number like 0.45. Okay, 0.45 molar concentration. That's the initial concentration of calcium ions. Use the pH of the filtrate to calculate the hydroxide after synthesis. So the hydroxide, how do we find out that? The pH is given to us. pH of the solution was given to us as 11.5. So POH then would be 14 minus 11.5 because the pH is 11.5, and that is 2.5 pOH. So the hydroxide ion concentration would be 10 base negative 2.5. When you get that, you will get the hydroxide ion concentration something like 0.0032. I put it in two significant figures, 0.0032. Okay, and that is the equilibrium concentration of hydroxide ion. So you can put that here, 0.0032. And the initial concentration of sodium hydroxide was given to us as 0.3. So if the equilibrium is this much, change is then going to be 0.3 minus 0.0032. So that's going to be the change. That is 0.3 minus 0.0032. 0.297. I would say 0.297. I mean 0.2. Let's do 0.297. 0.297. That's the change of hydroxide. You see the ratio, molar ratio is 1 to 2. If the change of hydroxide is 0.297, so then the change of calcium ions, right? So the change of the calcium ions then would be 0.297 divided by 2. That's the change, right? So 0.297 divided by 2, 0.149. 0.148 or 1.149. Say 0.148. So the change is going to be 0.148. Okay, and then the initial concentration, we calculated the initial concentration, which is 0.45, right? That's 0.45 for calcium ions. This calculation is exactly similar to what you did for our pre-lab calculations for the same experiment. Okay, so then the equilibrium concentration would be 0.45 minus 0.148. Excuse me, 0.308. 0.02, not 82. 0.302. Okay, now we know the equilibrium concentration of calcium ions, also equilibrium concentration of hydroxide ions, and with that we can calculate the Ksp, right? So the Ksp is going to be calcium ions, and then the hydroxide ions, you need to raise it to the power 2, which is 0.302 times 0.0032 raised to the power 2. So you can find out the Ksp like that. Okay, that's how you calculate Ksp from the by making the calcium hydroxide. And then Ksp calculated from the saturated calcium hydroxide. Use the pH to calculate the hydroxide in the solution. So the saturated solution pH is 12. So we can find out the hydroxide ions. How? By using pOH equals 14 minus 12, which is 2. So hydroxide would be 10 base negative 2, which is 0.01, right? That's equilibrium concentration of hydroxide ions, which you can put here, 0.01. Okay, and then again ratio is 1 to 2. If the equilibrium concentration is 0.01, so the high calcium ions going to be half of that, right? 0.005. Because initially, since we use this from the saturated solutions, these are going to be 0. If the equilibrium concentration is 0.01, your calcium ion is going to be half of that, 0.01 over 2, 0.005. Okay, now that you know the equilibrium concentration and hydroxide concentration, we can find out the Ksp. So the Ksp then would be 0.005, 0.01 raised to the power 2, and then you will write down the answer. Okay. In this lab we used two different determinations of Ksp. Did you find that one of the two methods was more accurate than the other? Propose a possible explanation for your results. So I will give you the correct original value for the calcium hydroxide Ksp. Calcium hydroxide Ksp is 5.5 into 10 to the negative 6. That is the literature value. Ksp, calcium hydroxide, literature value, meaning the experimentally determined value that you need to compare, is 5.5 into 10 to the negative 6. Now you're going to be getting an answer here. Also you're going to be getting an answer here. You look at the two values and see which one is closer to the original value. And then you can see which one is more accurate, and then you can come up with some reasons, possible explanation for your results. Okay, and then choose your more accurate Ksp value to calculate the percent error in your Ksp and discuss possible reasons your value may differ from the accepted value. So you choose the most closest one, and how do you calculate the percent error? You did this percent error calculation in Chem 1. Percent error is going to calculate, you take the absolute error and then you divide it by the actual value times 100. And how do you calculate the absolute error? Absolute error is accepted value. Accepted value is going to be the literature value, which is going to be 5.5 into 10 to the minus 6, and you subtract the experimental value. Experimental value, I put V just for the value, which is what you're going to be putting here from your calculations. So these two bars on the side indicate whether you get a positive or a negative number. You always have to write the positive value, and this you're going to divide by accepted value, which is again is the literature value, which is 5.5 into 10 to the negative 6. So your accepted value is going to be 5.5 into 10 to the negative 6, and then the experiment value is one of the two Ksp values that you calculated, which is more closer to the accepted value. Once you get this, you first subtract and then divide by accepted value, and then you multiply that by 100 to give you the percent error. That's how you calculate the percent error. Okay, all right then, bye.